All right, so yesterday we were writing polynomials in factored form. They didn't give us the leading coefficient, so we were putting a in there to hold the place of that leading coefficient. And every single time we want to make sure that it's matching the degree that they're giving us. So I just want to look back over the ones that we did yesterday. Yesterday we were supposed to write a degree 3 polynomial for part A. Did we accomplish that? Yes. What evidence can you provide for that? We have 3 x's that are all to the first power. We have 3 linear factors. So when we add those exponents, because they're all first degree, we get a degree 3. Make sense? Okay. Part B, we were supposed to write a degree 4 polynomial. Did we succeed? Yes. We had 2 linear factors and a quadratic factor. So when I add the exponent of 2, 1 and 1, I get a degree 4. So far, so good? All right. I want to walk through the same basic process here on part C. So I'm going to call it C of x, because why not? What do I have to have right after the equal sign? I need my leading coefficient, because they didn't give that to me and they didn't give me any information with which to find it. I'm going to put A in that spot. What else do we have? What would another factor be? X minus 2. Would that have any exponents on it? No. It says it is multiplicity 1. What would another factor be? X minus 1 squared, because here it tells me that it has a multiplicity of 2. So this is a double root. Then it says 3i is a 0 here. What does the I represent? It is imaginary. Well, let's write our factor down. What would it look like if I had an imaginary 0 at 3i? What if it was just 3 instead of 3i? X minus 3. So this is going to be x minus 3i. Did they give me any other zeros? And they said this was supposed to be degree 5. Have we written a degree 5 polynomial? No, we've written a degree 4 polynomial. Here's the thing about imaginary roots. They always come in pairs. If 3i is a root, then that naturally implies that negative 3i would have to be a root. The only way we find imaginary roots is either by using the quadratic formula, which has a plus minus and a square root, or we use the square root property, which would still require taking a square root. And when we take a square root, we find how many solutions? We find 2. We always find the positive one and the negative one. So 3i being a root, this implies that negative 3i must also be a 0 of this function. Anytime you see an imaginary root given, its positive or negative counterpart has to also be a 0. So what would another factor be here then? X plus 3i. Now, I want to talk about these guys for a minute here. When I see a polynomial written out in factored form, have you ever seen something like that show up in factored form? No, and normally things with imaginary roots, if I asked you to factor it, you would say this does not factor. Doesn't mean I can't find the zeros, but it does not factor. So I'm going to multiply these two together. We're still going to be leaving this in factored form, but I need to multiply these two together here. What do I get when I distribute these? X squared plus 9. Yes, because I have plus 3i minus 3i minus 9i squared. This part cancels out, and you know that I squared is equivalent to what? This is the same thing as -1. So I have -9 times -1. So this whole thing right here is equivalent to x squared plus 9. So my polynomial here in factored form, c of x is equal to a times x minus 2 times x minus 1 squared times x squared plus 9. I want to stop here for just a moment before I circle it and call it done and make sure that it meets all the criteria that we've been talking about so far. Starting with, are we degree 5? Yes, I have an x squared right here, so that's degree 2. Here it's degree 2, so that's 4, and here I have a linear factor, degree 5. If I gave you a big, long polynomial and I said, factor this, and you got it to this point, and I said, does this factor any further? Does that factor any further? Does it factor? It doesn't factor any further. That doesn't mean I can't find the zeros. But that, is, I would say, is not factorable, which is why I'm leaving it in my factored form. Does that make sense? I don't want imaginary things in factored form. Yes, sir?
Will we get points taken off if we didn't let it like that?
If you left it like this? If I'm not mistaken, on the homework, on the quizzes, on the tests, I don't believe I'm having you leave things like this in its factored form. So it shouldn't be an issue. If it is, I'll make very sure to clearly state, make sure your factored form contains no imaginary numbers, etc. So, and if you have any questions about whether or not you would get points taken off or something like that, you're always welcome to ask that kind of a question during the test. All right. So this is where I would leave this one right here. All right. I want to keep rolling with this big idea, but instead of leaving it in factored form, we're going to take it the next step and put it into standard form. How would I take something from its factored form and change it into standard form? Multiply it all out. And that's what we're going to do next. So we're going to write it in standard form, which means I need to start with my factored form. And then multiply the factors together. There's something kind of weird looking here that we didn't see on the previous example. It tells me my zeros, cool, that's how I get my factors, but then it has that satisfies f of 6 equals 180. Why have they given me this? What am I supposed to use it for? We will use this to find a. All right. So f of x equals, what information can I write with just the zeros? Absolutely. And what else do I have to make sure to put in there as a placeholder because I don't have it yet? Put your leading coefficient a in there. And then we have our factors, x minus 4, x minus 1, x plus 5. At this point, I'm going to substitute in, oh, sorry, x plus 3, thank you. I don't know where I got 5 from. I'm going to take f of 6 equals 180 and use that to substitute in. What are we putting in the place of the x's? Putting 6. So I have 6 minus 4 times 6 minus 1 times 6 plus 3. Got my a out here at the front. And what is going to take the place of f of x? 180, that y value. All right, so I have 180 equals a times what? 2 times 5 times 9. 2 times 5 is 10. 10 times 9. So I have 180 equals a times 90. So what is our leading coefficient, our value for a? 2. Using that information, I now know that I have f of x equals 2 times x minus 4 times x minus 1 times x plus 3. So far, so good? How many things can we multiply together at a time? 2. I can multiply 2 things together to get a single product. But I can only multiply 2 things together at a time. How many things are we trying to multiply together here? 4 things. I've got that leading coefficient and then 3 factors. So I'm trying to multiply 4 things together. I'm going to have to break this into pieces. So I'm going to multiply these first 2 pieces together. That would give me 2x minus 8. And then I'm going to multiply these 2 factors together. So x squared plus 3x minus 1x minus 3. And then I'll multiply those 2 together. Can I clean up what's in red first, though?
Yes.
Yeah, that would be x squared plus 2x minus 3. I'm going to do that before I distribute it to my binomial in the front, 2x minus 8. So now I'm going to distribute 2x to everything, so I get 2x cubed plus 4x squared minus 6x minus 8x squared minus 16x plus 24. So far, so good? Last thing I need to do is combine any like terms together to finish simplifying this and write my final answer. So I have f of x equals, what would my leading term be? 2x cubed. How many x squareds do we have?
2, so 4x squared minus 8x squared.
Yep, I've got 4x squared minus 8x squared, so negative 4x squared. I have negative 6x and negative 16x. When I combine those together, I get what? Negative 22x plus 24 on the end. And that would be my final answer here. Let's do part B. We're going to write this out first with my placeholder for my leading coefficient. So f of x equals a times, what factors can I write from my zeros? X plus 1, x, x minus 2, and x minus 4. How are we going to find a? Yes, 63 goes in the place of f of x. And we've got 1/2 in the place of x. So I have 1/2 plus 1 times 1/2 times 1/2 minus 2 times 1/2 minus 4. I would absolutely leave this as fractions because you don't get a calculator. So if you're working with decimals, it's going to get real messy. If we leave them as fractions, I multiply my numerators, I multiply my denominators. What is 1/2 plus 1 written as a mixed number? Sorry, not mixed number. Improper fraction, my apologies. 3/2, 3/2. And then I have just 1/2. 1/2 minus 2 would be negative 1.5, which would be what as an improper fraction? Negative 1.5. Negative 3/2, yes. And then I have 1/2 minus 4. 1/2 minus 4 is negative 3.5, right? Which is what as an improper fraction? You were correct. Negative 7/2, yes. Multiply our numerators together. What do I get when I multiply just those numerators? 63, because I have 3 times 1 times negative 3, so I had negative 9 times negative 7. I get a positive 63. Down on the bottom, I have 2 times 2 times 2 times 2, or 2 to the 4th power. 16. That is equal to 63. How am I going to make the 63 over 16 cancel? Multiply by the reciprocal, 16 over 63. If you do it to one side, you've got to do it to the other side. So it's going to cancel here. Over on the left, 63 over 1. I multiply top to top, bottom to bottom. What's going to happen?
It's 16.
Yep, my 63s will cancel. So I have 16 equals A. Lots of work there. All right, my function, f of x, I now know my leading coefficient is 16 times x plus 1 times x minus 2 times x minus 4. Only multiply 2 things together at a time, but I think I can do this right here because the 16 and the x, I can just take a 16x and distribute it to that linear factor. What would I get when I multiply all these pieces together? Just right here inside the blue. 16x squared plus 16x. And then we're going to multiply these two factors together. So I have x squared minus 4x minus 2x plus 8. What's that one going to be when I combine my like terms? Yes, x squared minus 6x plus 8 here. 16x squared plus 16x needs to get distributed to all of that. So I'm going to have 16x cubed minus, what is 16 times negative 6? Negative 96x, sorry, this should be x to the fourth at the front, my apologies, because I had x squared times x squared. 96x cubed plus, what is 16x squared times 8? 16x squared times 8. 128. So 128x squared. Then I take 16x and distribute it. So plus 16x cubed minus 96x squared plus 128x. Combining like terms to get my final answer, which will end it for today. 16x to the fourth. What do I get when I combine my x cubes together? Minus 80x cubed. What about my x squareds? 34. I think it's 32. Yeah, 32x squared plus 128x. All right. We'll do a little bit more of this on Monday, working from graphs. We'll leave those in factored form, but we will still find our leading coefficient. Have a fantastic weekend, guys. I'll see you on Monday.